Lecture 35, DevOps for P4P. Thus far, we've really talked about one-off computations. You need to answer a question, you write a code to do that. And assignments are a pretty good example of, a one-off kind of thing. You implement the assignment, TA evaluates your assignment, a grade is assigned, the end. You never have to see it again, you never have to think about it again. And there are lots of programs in the world that are really just on demand when you want to, schedule classes for the upcoming term or whatever. You run it, it produces a solution, it gives you that solution, and that's it. You don't really need it to stick around and be continuously operational. But that's not true of every kind of software system. A lot of the time you want to keep it running all the time, and it's available when you need it, and you call into it when it is going. Sometimes you are making an explicit promise to another entity, whether that's another company or just end users, where you say, look, the service is going to be available for, always and at all times. So not Quest, but something similar to that. Your product responds to requests, and that gets us really into the subject of operations. And you might think, well, listen, why do I care about operations in the context of programming for performance? And I'll tell you that when we talk about, those ancient computers where, people had to wire things up by hand and, manually connect the switches and do this and do that, and it would say, oh, well, it can compute this operation in or X operations per second. And it would sound like an impressive number, except for the fact that you can do the calculations exactly one at a time, and then a large amount of operator time has to go into resetting it. So in that case, not as good, not what you want, and not very efficient. And you could say the same thing when it comes to programming for performance, that although you might have very low latency on something, if you have to, shut it down and restart the application after every operation, you will find that your throughput is not very good, and so operations kind of matter. Your product or service is much more likely than ever to have at least some component that's server side, whether it's hosted in a cloud service or not, and so it's going to be under your control and your responsibility to keep it going. And the theme today is using our skills that we have from software development to actually undertake some stuff with system administration, database management, etc. There's relevance here because operations, or if you call them IT, have processes and procedures, and they are different from development, but there are some similarities. And even when we talk about cloud computing and what have you, it's somewhat about keeping your system alive for a long period of time. And many companies have a fusion of development and operations, hence DevOps. So I'm going to take these two words and smash them together, and it's going to be a portmanteau, and you can click on that word in Wikipedia because it appears at the start of practically every article somehow. Right. Depends where you work, of course. Some companies do have a dedicated operations team, and you write the software and you give it to the operations team. But that tends to lead to this, ops problem now. Thanks, Disaster Girl. You don't want that, and the people in the operations team don't want that, and it's just unpleasant overall. You want, hopefully, to be able to work closely with the operations people. I mean, there will be, people who are specialists in this, and it's their primary responsibility and their primary duty, but it's no longer, all right, we're over here, they're over there, and when we're ready, we deliver them a package, and then they figure out how to deploy it. Doesn't work. Obviously, at a startup company, there would be no separation at all. There isn't really enough money to pay for a separate development team and separate operations team. And also, the amount of dedicated operations people that you need is probably small because there's not that many servers. There's a demo system, there's a couple test systems, there's a production system, and so on and so on. But as your company gets bigger and you have more customers and more environments and what have you, these things end up spiraling, and you slowly build them out, but eventually you wake up one day and you're like, wait, why do we have 300 servers that we're managing? You didn't add them 200 at a time. You added them, one or two at a time, or, we need this service, or we need another replica of that, and very quickly you end up with a lot overall. And the thing is that in your startup company, in your small company generally, you don't have a lot of choice, because the development people are the best people in the organization to manage your servers. You're not going to ask the sales team to do it, are you? Impractical. A little bit impractical. Maybe they can. Most likely they can't. So for this reason, there is DevOps. And is it a good idea? Well, this is one of those... anything could be used for good or evil depending on who is wielding it and for what purpose. So it's hard to write down and say, for sure 100% of the time this is good or 100% of the time this is bad. That's not fair. But there are upsides, and one of them is that developers are involved across the whole software lifecycle. It's not just, we compile this and we ship it and that's it, the end. They are actually involved in what it takes to get it running and understand how it's deployed, and you can really learn a lot from that. And you're also motivated by doing that to use good tools and document processes. Because, it's painful if you do it otherwise. If I can give the problem to the ops team and say, yeah, deploying it sucks, but whatever, you guys figure it out, I don't have very strong incentive to make deploying it nice. If I feel that pain personally, that gives me an incentive to say, hey, I'm going to do something about it. And it's well known in software development that, if something is a problem for another team, somehow those tickets just never quite make their way to the top of the backlog, do they? Oh yeah, it would be nice if, but we have this other thing that's very important. We promised the manager that we would do this, or we promised a customer this, or we're counting on this to have a good product demo at the end of the month. And sure enough, those little operation pain things just magically slide down the list. Okay, so here's a couple of suggestions for managing things. And the first one is you should always treat configuration as code. Systems have really come with a lot of complicated configuration options. They try to pitch it to you like it's a good thing by calling it flexible. As I think we've discovered at this point, the defaults are usually fine for a lot of situations, and giving users options just makes it more likely that they choose the wrong ones, and therefore anything we could do that would reduce that is good. SendMail is particularly notorious, but there's also ProcMail and Apache and other things. So all of those Unix type stuff have some reputation for being infinitely configurable, but somehow very hard to use. But if we choose to treat configuration as code, that very naturally leads us down a couple of roads that see to it that we make good decisions about how to manage what we've got. And that means we use version control on the configuration, and therefore it's not just, whatever the configuration is happens to be written down somewhere on somebody's hard drive. That's not practical, that's not sensible. So you wouldn't do that, but you would have configuration saved in version control, meaning that changes are tracked, and it's easy to undo something if that configuration somehow was incorrect. Implement code reviews on changes. Again, treating it like code means that somebody should take a look when you want to make a change and verify that it does what it's supposed to do, and there's no unexpected anything. And making good use of the code review process is a good way to ensure that no tiny thing is overlooked, and oh no, we forgot a comma and now it crashes. On startup, anything like that could be easily caught by a code review would make it a lot more pleasant to work with. Test your configurations. This means that you want to verify that they generate expected files or start expected services. So we're checking, what are the behaviors or what are the outcomes of running your configuration deployment. If you don't check for these, then deployments that fail won't be caught somehow until the deployment itself actually fails, which is probably not what you want. So you want to be careful about what you are testing. For other things, what you're interested in is convergence. That if you're running an app, the app is supposed to perhaps not terminate, in which case waiting for it to be over and checking the result doesn't make sense. But you want to make sure that the CPU usage decreases after some initial startup costs, where there might be some significant CPU use, but it decreases over time. And eventually reaches a steady state, and steady state is a reasonable amount. It's not maxed out at 100% CPU. Something like that would be something you could check in testing your configuration by doing a test deployment of your application and seeing if it does what you think it does. Next item in the list, aim for a suite of modular services that integrate together smoothly. This is not too different from other advice about not building giant monolith systems that somehow aren't very modular and have a lot of overhead associated with working with them. We have to deploy this big app and it takes forever because reasons. The small systems that work well approach is not just trendy, but comes recommended at least of late. Refactor your configuration files. These could be Puppet manifests, Chef recipes, Kubernetes stuff, anything like that. You should treat it the way you treat code, which is when there is a need, you refactor it to make sure it is clean, tidy, up to date, that kind of thing. Making sure that you don't pay these costs one day when you're like, oh no, suddenly we have to, because of a security vulnerability, update something, and it means we have to change 500 lines of configuration because we haven't done any updates in a long time, and it's a mess. Keeping on top of it is beneficial. And use continuous builds. We'll revisit that later. I would be very surprised at this point if I had to tell you that continuous integration is something that you want and or need, but no sense in skipping it since it is important. The best idea, of course, is to use tools for your configuration. I don't really consider it sufficient to have a wiki page or GitHub document titled "How to Install Awesome App," fill in name of program here. The more complicated the process is, the more likely it is that people will forget something. People make mistakes, and ultimately you want to take it out of their hands as much as you possibly can, just so there are no possibilities for error if you can avoid it, right? Anything that makes it automated is going to make it more likely that the right thing happens. So you want that. People make mistakes. People are human. One particular example of applying these principles to infrastructure is Terraform. And Terraform is, again, I'm not giving it in particular an endorsement, I'm just using it as an example. Its whole purpose is managing your configuration as codes. So when you want to run your code using a cloud provider like AWS, you control the infrastructure using Terraform. So you can, in the web UI, go into AWS console and say, look, I want to create this instance, and I want to do this, and I want to do that, and it will gladly accommodate you. But that's kind of inefficient. It would be better if you instead use some automated method for configuring it, and that's what this is about. That's what Terraform is for. You write configuration files. You say, I want my service to have these permissions and any other details, and then you can apply that configuration easily. And Terraform also supports a plan operation where you can say, look, based on the configuration files, I want you to tell me, what will you do if I tell you to do this? And Terraform will give you a breakdown of, all right, here's what's going to change. These things will be added, these things will be updated, these things will be deleted, and all of that is very helpful in making sure that you know what's going to happen. For some fields, it doesn't tell you the exact value. If you are updating something and it's going to be assigned a unique identifier, it'll tell you, well, the unique identifier will be determined when it's created. But otherwise, that's okay. But the ability to look it over and see what is going to happen is nice, just as a double check that you're not going to accidentally destroy something that you didn't mean to destroy. You're not going to change something that wasn't supposed to get changed. You are given a little bit of extra security in that regard. If you're happy with it, apply it. And then there are containers, and in the real world, when it comes to physical goods and services, physical goods at least, it's very hard to think of any innovation that has changed the world more than containers. The shipping containers that you see in the screen. If there's anything in the room that you're sitting in, there is probably a 90% chance that it at one time or another was in a shipping container. And it's because so many things are made in different countries and shipped around the world, regardless of where you are, and because factories put things in shipping containers before they even leave the factory, even if it was made in the same country that you're sitting in, it was likely in a shipping container at some point. To talk about containers when it comes to the computer sense, I think we should take a little digression for a history lesson. And how did we get here? Well, there were a few things that get us from one place to another, and we'll start with manual install. So, this is the original approach where we don't really have any tools helping us to do the installation. It is just we get started. Somebody gives you a binary file, or you compile the binary file yourself on the target machine, and then you modify the configuration file, you install it, you get it set up. It's made a little bit easier because there are sometimes configure scripts which look at the capabilities of the system that you're working with and make changes appropriately to make the configuration match what you've got. But ultimately, that's inefficient. So then you get package management. And don't get me wrong, I don't think there's anything wrong with package management as a general strategy. If you are making a Linux distribution, you want package managers, and you can have packages, and if you're Rust, you have cargo, and it's package management as well. But adding your own apps and things like that to a package management system is a strategy that you can employ for deploying your code. I don't know that it's necessarily a good one, though, because there does exist the possibility of what we call RPM hell, or jar hell, or DLL hell, or class loader hell, or that kind of thing. Because if you install multiple services on the same machine, you don't get isolation, and you can have incompatible versions of dependencies, meaning that you can't install this because, well, it needs the wrong version of that, which is needed by something else. And it is ultimately a small problem, but an annoying one if you can't find a way to make a version of everything that aligns. Okay, so then you say, look, we should have virtual machines. You configure the VM parameters, and you install the guest operating system, and you set it up, and you can copy and paste the initial image, which helps. But for every application, you have a guest operating system running underneath. And maybe, actually, when it comes down to it, you don't need that. That this is overkill. Why do we have to install the same security patch in every one of the guest operating systems? You got to log into each virtual machine and sudo apt-get update every single time. I mean, yes, you can automate those things, but why go to that extra effort? Why install it 10 times when you could install it once and be done with it? That would be better. And then there is containerization, which is kind of the next level of that. And containerization gives a lot of the advantages of separation, but without nearly as much overhead of the guest operating system, both the maintenance costs and the runtime costs. And so what we see is something like this, comparing virtualization versus containers side by side. Containers are run by a container engine, so there is some abstraction of the underlying hardware, and a container is assembled from a specification that says, here's the libraries and tools and whatever that I need, and when the container is built and deployed, it's sufficiently isolated but shares in read-only mode where it can. And so you could think of a container as being like a very lightweight virtual machine, which is an improvement over having a virtual machine for every single application that you want it to run. Compare the version on the left here, where we have machine virtualization with the hypervisor and a bunch of guest operating systems, versus the container engine approach, and this is potentially a significant savings. Containers, however, do come with a potential downside in that it doesn't ever force you to upgrade things. Whereas before, if you installed an operating system patch, you could be forced by that to upgrade your dependencies because, well, this patch includes a new version of some shared library, and there's a breaking change in there, and we got to deal with it, and there's nothing we can do about it. However, that's no longer the case. You can just keep an old insecure version of a library around forever. So you need an incentive, and the incentive should be that if something bad happens and data is leaked or something, you could be having a fun talk with the GDPR people, where they take you for a lot of money. So you don't want that. Stay out of trouble, as RoboCop would say. So keeping on top of these security updates is important. In fact, we're going to talk about that because keeping an always available service accessible over the internet makes security a very big concern. So security, report to the bridge. Okay. You can run programs with tons of security vulnerabilities offline and feel like you can manage these security vulnerabilities and it's no problem. I know the university has, in some cases, some machines running old versions of Windows with old versions of software, where we don't want to pay tens of thousands of dollars for a license upgrade or a new version when the old version works perfectly fine, but the old version doesn't run on a modern Windows machine, and therefore we have to keep around this Windows XP system. To mitigate the security impact of that, the machine in question has no network connection. In fact, like no network port. You can't do it. You can't connect it. You can manage that. Then the only possible vulnerabilities are somebody doing something nasty when they are physically in the presence of the machine, and physical threats are hard to defend against. Somebody with a hockey stick can really wreck your day if they have physical access to the machine, even if they're not any good at hacking. When the machine is online, the risk is enormous. And it's not a security course, so I'm not going to talk about all the details that you would normally cover in a security course, but there are two things that I really want to call out that are worth talking about. The first is code execution or code injection, and then the second one is data leakage, also called information exposure. Okay. Code execution is exactly what it sounds like. It is attackers run their code using your platform, right? They find a way to put some code into your application or into your server that executes, and it runs on your hardware inside your systems, and the call is coming from inside the house. They mess with your data, they send spam, they send harassing emails to your customers, they can take services without paying for them, use your machines to mine Bitcoin at your expense, and many other things, and sometimes that kind of thing is a company-ending event, right? If it comes out that your server has been compromised and it's been running arbitrary code and performing a denial of service attack against some U.S. government website, you're in big trouble. You don't want that. information exposure is not only terrible for your company's reputation, but violates privacy laws and data protection regulation. In fact, a breach of the EU GDPR, General Data Protection Regulation, can get very expensive because it's based on your revenue, not your profit. And we can actually visit enforcementtracker.com to find which companies have recently gotten their wrist slapped or a huge fine. At the time that I wrote it, the record holder was Marriott International Inc., yes, the hotel chain, of the UK, with a fine of 110 million euro, 390,200 actually, which at the time is roughly, using the exchange rates of October 2020, 171,898,556 Canadian dollars and 93 cents. Not exactly pocket change, is it? Looking at the GDPR enforcement tracker, it is by default sorted by date, and I'm recording this on the 29th of December, so you can see the most recent one was assessed yesterday against a company in Poland for insufficient fulfillment of data breach notification obligations, which is to say that if a data breach has been identified, you got to own up to it, even though that's painful to do. If we sort here based on the fine, it appears that right now the most expensive one is against Google Inc. in France for having insufficient legal basis for data processing. The next one is H&M. I believe it's a clothing conglomerate in Germany, then a telecommunications operator in Italy, British Airways. I guess Marriott International got their fine toned down from 100 million euro to 20 million euro. Big savings. I mean, I guess I wouldn't turn down 80 million euro now that I think about it. The fines can be quite expensive for the various companies, the enforcement tracker really gives you a significant breakdown of what happened and why. And for the most part, you can see that insufficient legal basis for data processing is expensive, that you're only supposed to have, under privacy laws, data for a valid purpose, and not everything is a valid purpose. I want it is not a good reason, it turns out. That's, I guess that's reasonable. But then there are also things like insufficient technical and organizational measures to ensure information security, and that's the kind of thing that's more relevant to us when we're talking about, are we doing the right thing with the user data? If we're not applying the correct technical measures, we're not taking appropriate precautions, that opens the company up to a whopping fine. Deciding what information to collect and not collect is probably made by management, although if something shady is happening, you should feel a responsibility to speak up and object and say, hey, I don't think this is okay. This isn't a class in ethics, although that could be an interesting side discussion if you wanted. However, in particular, the one for insufficient technical and organizational measures is something that we are worried about. And you can see it takes a couple pages before we get down below the 1 million euro mark. And I don't believe any country in particular is an especially bad offender. Ultimately, there are a lot of cases where it's insufficient technical and organizational measures to ensure information security, so don't let that be you. Now, you're not alone in the fight, because there are companies that will, in exchange for money, check your code for libraries with versions having known security vulnerabilities, and it's also transitive, so that if you import a library that depends on a parsing library and the parsing library has a vulnerability, that's noted and reported. And each vulnerability is usually assigned a severity, and the service could say that if you update from version 10.12.0 to 10.12.1, that will solve the problem, and they can say this because they observe that a vulnerability that was reported in one version is reported as fixed in another version. Unfortunately, though, it's not always just so easy as to change a number in the configuration file and say, yep, we want version 10.12.1, because there could be breaking changes. an upgrade might be more painful than just the recompile that would take place in that scenario. It also might take some time for libraries to correct and release a fixed version of the library, that when the vulnerability is known, hopefully there's a fix available, but maybe not. And you will have to implement some mitigation of your own if you think it is a serious concern for your use case, or just keep an eye open for when the patch is released. Because something might not be available immediately, there is usually the option when you have one of these dependency checkers to just snooze an alert and say, all right, I can't fix it right now, please ignore this temporarily. Tempting as it is to do that and just get on with your work and get your PR merged and call it a Friday, you shouldn't. It's leaving a vulnerability in your code, and good practice would be for reviewers to discourage the ignore approach unless it cannot be avoided. As with other parts of your application, checking for vulnerabilities should be an automatic part of your process for build and release. At the very least, release, but certainly build. And if you are doing something that is really truly very sensitive, you're working with people's medical data or something like that, you may also consider having a security auditor, whether internal or external, whose job it is to give a little outside perspective and check on things and make sure that all is going well, and that user data is sufficiently protected, because again, don't want to get in trouble. It would be bad. All right. Our next topic is titled as server as cattle, not pets, and servers means actual physical machines or virtual machines or containers. It's whatever, actually all of them if you're managing all of them, or whichever ones of those that you are managing. And the idea is that you should be using mass tools to manage your servers and not doing one-off changes where somebody logs into the box with Secure Shell and says, all right, I'm going to do this change, I'm going to do this, and I'm going to do that. That's inefficient because you're doing the tasks manually. What you want is cloud-like server initialization without manual intervention, and you want to be able to, at the very least, spin up a server without having to do anything other than programmatically, just order it. If you do it well, you can save a lot of hours of time, and also it enables automatic scaling where servers are started and stopped based on incoming demand for your services. The idea references the idea that cattle are dealt with as a herd. You try to get the whole group to move along and do what they need. And pets are individuals. You treat them all differently. The amount of individual attention very quickly becomes unmanageable, so you want to stay away from that. As with managing infrastructure, I'll give you a specific example, Kubernetes. This is used to automate deployment and scaling of applications, and it means you don't have to manually manage them. If you want to deploy a new version of a container, you just tell Kubernetes, please do it. The part about how it does so is, well, it provides a framework for your environment. The details are something that you can investigate if they're relevant to you. But from a deployment perspective, you can just say, look, this is what I want, and it'll say, all right, I'll figure out a way to do it. And it can do load balancing, automatic rollouts, reverts. It can keep an eye on whether a particular deployment is healthy or not, shut them down if they're having trouble, all that kind of stuff. And it will figure out what instances run on hardware, replace them if they die, anything like that. Another thing that you want is common infrastructure. And you should be using APIs to access infrastructure, and that is, you should view different parts of your infrastructure as having an interface, and communication is done via that interface to prevent coupling between different components and scale the parts that need scaling. And so for storage, where does data go in the long term? Where are you sending your log files? Where do uploaded files go? If we generate a CSV file, where is it? That kind of thing could be done through an interface. So you put it in S3, or you have a file server, something like that. Naming and discovery, figuring out what services are available and what the what the services offer, like what APIs they support. Again, could do it with an API. And monitoring, same thing. Monitoring is also probably done via an API. Health checks on your services and reporting metrics via some metrics endpoint, something like that is good. You should try to avoid writing your own software for any of these things. It's usually better to use some open source tool or the ones that are supported on your cloud management console. Trying to rule your own is not usually very effective. You might have to. Sometimes what you want or need doesn't exist yet, but I want you to, before you decide, oh, we're going to write our own, how hard could it be kind of thing, think very carefully about this. Number one, is the service really part of your company's core competence? And does creating it add sufficient value to the business? It's fun to make your own thing, and it's great to like start with a greenfield project and be like, yeah, I'm going to make my own naming and discovery service. Console already exists, but if I wanted to, I could make my own. But is it a good idea? And one of the things that I ask, and this applies, not only to what is the company doing, but also like what are technical staff doing with their time, and it is, are you doing what you're best at? Right? Like some companies say, we don't want any junior engineers because, senior engineers can always do it better. And I guess that's true to some extent, maybe not always, depending on the junior engineer and the senior engineer in question. But also, are senior engineers doing what they're best at if they're doing work that could be done by a junior engineer, even if they might do it more efficiently? Are they doing what they're best at? And also, why are you depriving yourself of the opportunity to have junior engineers who are good and turn into senior engineers in less time than it would take you to hire that many? Never mind. This isn't about hiring or human resources or anything. The other thing that I want to tell you, of course, is that think extra carefully if you plan to roll your own anything that's security or encryption related. Unless you have experts on staff who know the subject really well and you're willing to pay for those external audits, you're more likely to end up with a terrible security breach and less likely a terrifically secure system. Remember, a breach of data protection regulations gets very expensive. And as a second follow-up soapbox to that, if what you're looking for doesn't exist, there might be a reason. Maybe the reason is that you're the first one to think of it, but maybe the possibility is nobody's built it because it's actually not that good of an idea. Either it's inefficient or is just not great in principle. So just think about it. We'll also talk about here quickly the rule of 10. And if you look at eBay, in 1995, the website ran via Perl scripts. In 1997, C++ on Windows. In 2002, switched over to Java. I couldn't tell you what they run now, but just gives you kind of an idea. That each of these architectures was appropriate at the time, but eventually ceased to be when requirements changed. And it's very hard to predict what's needed in the future, so don't get too attached to any particular architecture, but also don't expect that any architecture that sounds great and amazing and will be perfect for 100 million users is what you need right now when you have 100 users or 100,000 users. Planning for the future is good, but don't plan too far in the future. Naming. You might have heard this one before. Naming is one of the two hard problems in computing: cache invalidation, naming things, and off-by-one errors. And naming is one of those things where it is actually hard. Some suggestions, to use canonical one-word names for servers. You might name them after, regional dishes or something like that. Or you could use aliases to specify functions where you have, geography. So this is at the NYC data center. It is a dev machine. It is a SQL server and some serial number. So you end up with like nyc-dev.sql-1, and that makes a uniquely identifiable name. You could also choose the Java package approach where it's, live.application.customer.webdomain.com, or however you want to call it. But whatever you do, pick something and be consistent. Making things inconsistent inevitably leads to errors down the road. Like if you're going to call production prod, always prod, never production. If you're going to call it production, always production, never the short form. Otherwise, you end up with problems where, like, well, I was writing into this Kafka topic and I don't understand why it's not being picked up. And it's like, well, you see, on the one side, the prefix being added is prod, and on the other side, the prefix being added is production, so they don't talk, they don't see each other, they don't even think the other one exists. You can avoid that by picking names and being consistent. Continuous integration gets a brief mention, even though it's really best practice based on version control and scripted deployments and stuff. But for the sake of making sure I don't leave anything out, continuous integration pulls the code from version control, builds it, runs some tests, reports the result. And what makes this work is there is like a social convention to not break the build. And these things get done automatically on every commit, and results are sent around, email or instant messenger or something like that. And you want to do it. In some places, breaking the build requires you to pay a little social penalty, buy donuts for the team kind of thing. You don't have to, but some teams kind of encourage that sort of thing. Canarying. Not this kind of canary. This is deploying code incrementally in production, also known as test in production. Not to be the most interesting man in the world, but I don't always test my code. But when I do, I test in production. No, the idea is that when you have something that you think is ready to go live, you stage it for deployment. You take some servers or some nodes out of service, you upgrade them, check that they're okay, and then reintroduce them into service, and also putting them back in the load balancer, and see how it goes. And in this way, not everybody is affected if the proposed change doesn't go as well as is expected. If there's an error that happens, a null pointer exception or something like that, things are okay. You didn't break it for everybody. Some users are sad because their request ends with an HTTP 500, but they could retry and may be successful. And you don't have to all of a sudden try to figure out, oh no, how do we undo this, and prepare a pull request that reverts it, and all that stuff. That's hard. That's annoying. If you have Canary servers, you get a try before you buy kind of experience, where you get the opportunity to see what would actually happen in production before it affects everybody everywhere. Obviously, to do that, you have to implement your system so that rollback is possible. If you made a database migration as a part of this deployment, that might not be so easy because doing the reverse migration could be hard. And then the monitoring thing is really the last topic that I want to talk about today. And it's because monitoring is surprisingly difficult. There are a lot of recommendations about what to monitor based on what makes sense for your application. And if you just care about monitoring things like performance, you might care about CPU load, memory utilization, disk space, how much disk I/O there is, network traffic, clock skew, application response times, all that kind of thing is used to check that performance is okay. If you're observing very high CPU usage, you could recognize that actually that is going to appear, as far as users concerned, as the application is running slow for some reason, right? It takes a long time to get a response. Why that is, why CPU usage is high or whatever, you don't necessarily know yet, but being notified of it by some automatic monitoring is a lot better than if you just find out because users are supporting or submitting support tickets where they say, hey, my application is really slow, I don't know why, help. That is one way to find out, and you will eventually find out about some incident that way, but you would prefer to be notified about it before users have figured that out. And you'll have multiple systems, so you need a dashboard of some sort that gives you an overview of all the multiple systems and a summary. And the summary has to be, not so detailed that you can't make any sense of it, but also not so broad that you can't tell if something is wrong. You can't be an overwhelming amount of data, but it can't also be a big thumbs up or a thumbs down, because that's not enough to tell you. You don't want to pay somebody to stare at the dashboard and press the red alert button if something goes wrong. What you actually want is not this, but automatic monitoring. And automatic monitoring, with my recommendation anyway, should have a couple of levels depending on what the expected severity of this problem is. If it is the highest level, it's an alert that is, human has to take action now, the database has crashed and didn't come back up. That's send somebody a page, get them to look at it, they need to fix it, they need to work on it right now. Then there are tickets. This is, we've observed something that maybe needs some fixing, but a human can look at it tomorrow. You don't have to wake anybody up in the middle of the night to deal with it. You can just say, yep, this is a problem, and somebody can address that problem during business hours. And then there is logging, where it's, I observed something strange and I'm going to note it down, but I'm not going to do anything about it. This is for forensic or diagnostic purposes. If somebody reported strange behavior, you could look at that and you could say, well, hey, I did notice that CPU usage was unusually high at this time. And that kind of thing would be beneficial in identifying what has gone wrong without it being any kind of, here's a real problem and we have to do something about it kind of situation. However, one potential bad practice is just dumping a log file into a ticket. Logs are usually very verbose and not always that easy to read. There are tools that parse logs for you and identify what's important, and you should take advantage of them. Highlight to the reader what is relevant. Don't make it their job to dig through a really big and really dense log file to look for the things that matter. It's important, looking at the fire alarm thing, to be judicious in the use of alerts. If alerts are too common, they get ignored. I mean, what do you do when you hear a fire alarm if you're in a building? Chances are you think, great, some jerk has pulled the fire alarm. It's a prank, or somebody wants to get out of their midterm or something like that. Very rarely do you think the building may be on fire and I have to leave now, otherwise my life is in danger. There are a lot more false alarms than real ones, and so with this in mind, you are in some sense trained to treat a fire alarm as no big deal. I'm sure it's fine. I don't think the building is actually on fire. If you're right, you're right. But if there's an actual fire, you're not wrong. You're not only wrong, but you could also be dead. So, if there are too many alerts, people ignore them and important things get missed. One of the projects that I'm working on now has to do with decreasing alert spam for an application that I have recently become a maintainer of, because alerts happen all the time and no one cares and no one looks, and they're reported and they just get marked as red because it's probably not important and there's no big deal, and it means you could definitely overlook something, right? You will, if it's always a false alarm, you will eventually end up losing interest in checking into every false alarm. So don't be like that. Being woken up in the middle of the night because some super critical ticket, OMG, kittens are endangered. That's a good way actually to learn that production code needs to be written carefully, reviewed, QA'd, maybe run by a customer or two in a canary deployment before it goes out to everybody, because there will inevitably be an incident or something like it, and learning some lessons from it and making sure that they don't happen again is greatly incentivized by the fact that if something goes wrong, you're the person that they wake up in the middle of the night to deal with the problem. So keep that in mind, and in this sense, remember the golden rule. Treat others how you would want to be treated. So even if you are not the one who's going to be woken up in the middle of the night or called in on what is ostensibly a vacation or a holiday to look at something that is on fire, write your code as if you were. And you can expect that other people should be kind enough to do the same for you. And if you do that, everybody has a better time, and nobody has to work on a public holiday because, whatever, it's somebody else's problem until that somebody else is future you. So be kind to others.